In this problem, we've been asked to evaluate a definite integral, but it's the product of two things. And I don't see an easy u substitution way to do this. But if I thought about simplifying this or distributing this in, we could rewrite this as the integral from 0 to 1 of x to the 1/2 times x plus x to the 1/2 dx, which can be written equivalently as the integral from 0 to 1 of x to the 3/2 plus x to the 1/2 dx. So now I'm going to use my power rule for integration, which says we're going to add 1 to each power and then divide by that new power. So we'll have x to the 5/2 divided by 5/2 plus x to the 3/2 divided by 3/2. And it'll be easier to evaluate if we multiply by the reciprocal instead. And it's also going to be easier to evaluate this if we rewrite these powers as 2/5 x to the square root and the 5th power plus 2/3 square root of x to the 3rd power, evaluated from 0 to 1. So we'll start up here evaluating our limits. We have 2/5 the square root of 1 to the 5th power plus 2/3 the square root of 1 to the 3rd power. And in both cases, the 0 limit will result in 0. So we're really just doing this first part. So I'm going to have 2/5. 1, square root of 1 is 1 to the 5th is still 1. So we're going to have 2/5 plus 2/3. To match our answer choices, we'll just need a common denominator of 15. We will have 6 over 15 plus 10 over 15, or 16 over 15.